Okay, so our next talk, we move forward in time to operations, is Jim Ingalls for the Science Center Operations and Data Management.
Hey everyone, I'm Jim Ingalls. I'm the lead of the CGI operations system here at the Science Support Center at IPAC. I'm going to be giving a talk that's doesn't have any data because everything we're talking about is going to take place in the future. My co-lead here at IPAC at SSC is Alexandra Greenbaum, who couldn't be here today. She's on maternity leave. She is the lead of the CGI Data Management Center, so we do operations and data management. And so this talk is going to be kind of a combo of both of our work. And it's been mentioned many times through this this workshop, but it takes a team to really get anything done. So all the work that I'm going to be talking about is really the result of efforts of many people. This shows the whole of SSC, all of the Roman support work that IPAC does. I'm going to narrow down in this talk to just these two boxes here on the left, which is CDMS, CGI Data Management, and COS, CGI Operations System. I'm the lead of the operations. Alex is the lead of data management. We work closely with the system support team led by Emmanuel and Jennifer, as well as SSC management led by Patrick, IPAC management led by George. We also do Roman support in general for community engagement, which is led by Skylar Van Dyke. And but a substantial amount of that work is exoplanet related and CGI related. And I'll talk a little bit more about that. So this basically gives a very short overview of all the work that IPAC does for Roman. The CGI work is in blue, and I'll just kind of bring that out now. These are the key points that IPAC does for CGI. Do exoplanet community support. Like I said, we have a community engagement team that creates the public website that contains the modeling that John mentioned. We do support for the CPP, and we also hold meetings and workshops such as this one. Then we work on coronagraph operations. So we're preparing to do commanding, telemetry monitoring, developing the tools for users to create observations with CGI. We will operate Skittle in this building. So the ground in the loop part of CGI's HOFUS gets done in computers that are right downstairs here. So we do the commanding and uplink, and also down the bottom data processing. So it's kind of split into the two kind of components led by myself and Alex. We also do assessing of and trending of health and safety from instrument monitoring. For data management, so we're doing a number of things, developing and operating a data analysis environment, basically for collaboration between the CTCs, technologists, the CPPs, community participation, scientists. They can collaborate there. They will have access to the data, which we will process at the low level from raw packetized telemetry into what we call L1 data, FITS format imaging. And then we'll validate and deliver all of the data to the archive. So SSC sits on in the ground system. We're part of the ground system. The ground system of Roman is the means by which an observer gets their wishes for how to use the instrument to the instrument. But it's also the means by which they receive data from the instrument. So all of the components of the ground system serve that purpose, and it's centered for CGI on SSC. So we do real-time commanding through the Mission Operations Center. We run Hopeless Skittle through the Mission Operations Center to SSC. We do observation planning with the so the CPP and the CTC work together to plan observations using tools that we've created. And those produce products that go to the scheduling team over at the Science Operations Center, Space Telescope, and those get uplinks to the spacecraft through the MOC as well. The data come down through the SOC and end up at SSC, where our data analysis environment makes the data available for the users. So scheduling and observation must be done weeks or months in advance, because we need to program ground station contacts for the crucial Hopeless Skittle. We need to make sure we have the ability to be in contact and know when that's going to happen for the ground in the loop portion. And so we can't really do joysticking where we say, hey, I didn't like the way that turned out. Let's just point to the new target in a minute. We can't really do that. It's inefficient for one thing, and another, we just can't. It's not the way that the system will work properly. So the responsibilities breakdown. So Tim gave an overview of the CTC's work. We work closely with them to prepare operations. And the way that things break down tends to be that the CTC is defining the way that CGI works. They define alarm limits, and then we carry out the operation. So they define the alarm limits, we assess trend and health and safety. They deliver the command dictionary, they design the data collection scripts, which we call procedures, and deliver them to us. We execute the scripts. We write the scripts and execute them. So it's a very good piece of teamwork where we're kind of we're carrying out the plans and the designs of the CTC. So let's just wanted to touch on community support before I go on to operations and data management in more detail. So we host the public website, and that contains instrument parameters and simulated images that John mentioned. We do community participation program support. We're hosting a wiki for the CPP, as well as running meetings. It's all from the website. Yeah, so operations and data management. So we operate CGI through a combination of two different flavors of operations. We do have real-time operations for certain situations, but primarily Roman is run using what's called event-driven operations. That's pre-scheduled, pre-planned observations. And we work also with the scheduling team and with the CTC and CPP to properly set up the system, the infrastructure for doing that pre-planning. So we basically will build a system, are building the system that translates observation designs into onboard command sequences. We also have a data management system that is responsible for hosting the data analysis environment, which is a processing environment. It is where users will get level 1 data products, the lowest level data that we transform from telemetry to FITS files, and they will also be able to process data to higher levels there. We'll host that processing capability, and then we deliver to the archive, the data to the archive. And then Hopeless Skittle will run autonomously at SSC. We process the data from the scheduled high order wavefront sensing activities and then on the ground. And a lot of this work is very kind of interfaced with the community. The observation planning and the data analysis environment are strongly working in tandem with outside scientists and community members. So first of all, operations, two flavors: real-time operations, where basically we have computers downstairs, like I mentioned, where we host workstations that can connect directly to the Mission Operations Center, and you can send commands and view telemetry in real time. That system will be used primarily during commissioning, when observers need to interact very kind of rapidly with what's going on the instrument, as well as if we're going to be monitoring health and safety through that interface, and when we need to do anomaly resolution, real-time system will be what we use. As well as autonomously, this system runs the ground and the loop. And this is a picture of downstairs in the ops area. We have 6 computers running the assist command and telemetry software, which is provided to us by Goddard, who is the mission operations team. That system it's a command line interpreter of the STOL command and telemetry language, which has been mentioned a little bit here and there, but that is the main scripting language, the main language by which we will command CGI, need to use STOL. And the scripting that we're doing is essentially we will not be allowed to send pure primitive commands directly to the instrument. We need to script them up, make sure that there's certain handshakes that take place, make sure that the command completion has been verified, confirmed through telemetry, and all that is done using this scripting language. It's a very flexible language and very, very usable. So this operations center has a dedicated connection to the MOT at Goddard, and we've been testing it for quite a while. And most recently and most kind of officially in mission readiness tests earlier this year, as well as just a few weeks ago. Mission readiness test number 2 took place by including spacecraft in the loop. So that was the first time that we actually sent commands that went to the spacecraft. They were no ops, but we're able to at least see that they completed and got the errors that we required. And so this is kind of just a snapshot of what our system looked like during mission readiness test number 2. I was waiting for another participant to take care of to do their steps, so I was able to get up and take a photo. And then the second piece of operations is the primary way in which Roman is going to be taking data and running the observatory, and that's called event-driven. They're pre-planned observations, and what happens basically is there is a sequencing engine on board, SOSI, Science Observation Sequence Engine, that will interpret sequences of high-level commands that were pre-scheduled as an observation plan by the SOC or by the ground system, including the SOC and the SSC. That we all kind of have to get together and make sure we have a system that puts them together. And I'm going to talk a little more about that in upcoming slides. So that's basically observation preparation. So essentially, the SSC interprets the wishes of CGI users, which is this CTC and the CPP, into a language that's understood by Roman, which is STOL, command language, scripting language, and what's called visit files. So basically, the process here is observers will submit their observing parameters using a web-based interface that we've created called CPGS. And I'll talk a little more about that in the next slide. The output of CPGS is then delivered to the SOC, the scheduling team. They'll construct an observation plan, which is an ordered list of visit files. Visit files are the means by which observations are scheduled. sequential calls to the onboard STOL procedures. They're, the visit file designs, the kind of overarching structure of them is designed by the CTC. We then take those designs and adapt them to the ground system data model by for delivery to the SOC, which then codifies them as their scheduling software, as part of their scheduling software. And all CGI flight software commands, as I mentioned, and telemetry, they're invoked via scripted procs. So, so we work very closely with the CGI team to make sure we understand the commands and telemetry dictionaries and also test all of these procs at the test bed, which Tim mentioned. So the first step in producing an observation is the command product generation software, CPGS. It's a web tool that allows users to basically to set up their observation. So that there's target selection, reference selection, configuration of CGI, HOFIS parameters. There's the settings for the observation scenario. So basically, using an OS 11 type structure, you can choose the durations of each of the pieces. You can choose how many of the pieces there are, and configure it if you want it. Submit that, and it produces a file called an observation specification file. It's a text file. It's written in XML. It's basically has the ordered list of visits that you're going to want that your observations will need to invoke, as well as all of the arguments to the STOL procs that are at that high level of the visit file. So when that observation specification is produced by a user, we then do a little bit of packaging and send it to the scheduling system. The scheduling system will create visit files from that, where those arguments that were in the XML get placed in their context as calls to the different sequenced command scripts. And then that will be packaged up as an observation plan and sent to the spacecraft. So just a little status on where we are with the operations system. We have tested real-time commanding and telemetry and data transfer capability in two mission readiness tests. We built more than 100 flight procs for use during by CGI, primarily to aid the FFT and TVAC work that's been talked about, the procs have also been used to in the first test where CGI was connected to the spacecraft in this June. Subset of those, small subset, it's a very short test, but they were executed on the spacecraft successfully. They were run from a visit file, which is exactly what we wanted to do for the flight system. Visit file was hand edited. It was not created by the ground system, but nevertheless, it did follow was invoked by SOSI in the way that the flight system will do so as well. We're currently working on the system to create and execute the majority of visit files to carry out the tech demo. First official CGI visit file built by the ground system will be tested in mission readiness test number 6 coming up in December. And then there will be subsequent mission readiness tests that take care of various other capabilities of CGI, such as HOFIS, commissioning, calibration observations. That's all mostly happening starting the spring of next year. So it's really all going to start coming together. The ground system is going to start building that infrastructure that allows an observer to kind of enter some numbers on a web page and get observations that run on CGI in a flight like this. So now I'll shift gears and I'll talk about this data management system. So that's really Alex's purview. So he's speaking for her here, but the one of the main things that we do is we provide this data analysis environment that allows users to come in and process the data, have access to the data, deliver the processed versions of the data. And to get that working, we need to take these raw CGI data files from the spacecraft and convert them into a usable format. They're packetized telemetry. It's a critical process to reorder the packets and create what we call L1 data. Those are basically FITS files. We're inject information from contemporaneous telemetry into the headers, so that we're not just taking the image data that we have, but also the telemetry that is taken at the same time and associating them with the images in the headers. This environment is there for collaboration between various members of the community, the CTC and CPP. And then we will take the data that's resulting, the L1 and the L2 through L4, and perform DQA on the L1 and header validation on L2 and L4, and then send them to SOC for archive. So a little bit more imagery on the DAE. It provides direct access to the L1 data once generated, provides the processing resources. It's a common location to coordinate and pool your tools and data, and also will provide a summary of the housekeeping telemetry for users. Just a note that the L0 to L1 processing is all going to be autonomous. It's all going to be run in an automated fashion, as well as the delivery of the results to the SOC for archiving. And the HOFUS data processing is also built as an autonomous process. It will not require human intervention. A little more on these tools in action that we mentioned for data processing. So the L0 to L1 software has been used is basically, I think, primary way in which CGI data is now transferred into FITS files for use both in the GITL processing that's been done in INT. And here's an image, a TVAC image that had been produced, by the SSC L0 to L1 pipeline, and the header that goes with it. And as well, it's also going to be part of the official CPP pipeline. So this tool is very has become very useful for the users of CGI to get data in a format that makes sense. So CDMS status, we expect to have a prototype of the DAE available this fall for testing. And the CGI data reduction pipeline can be deployed there and confirm that we have the right setup for that. The CDMS modules have been built and used and integrated into the CTC software for INT processing, as well as for the HOFUS loop processing. Data processing for the HOFUS loop as a whole within SSC has been demonstrated for ground system release 2, which was in April of this year. So we actually have the capability to do our full HOFUS loop from data arrival to SSC to command production, all tested. The high-level architecture and database is being worked right now for CDMS, and we've been really kind of using a connection with the CPP to help us, giving us feedback on updating the file formats, as well as the header scheme for the L1 FITS files. And so now I wanted to kind of just give a kind of move over to talking about HOFUS, because as that is kind of a combination of the work of both the operations side and the data management side of it. So as has been mentioned, as Eric talked about, we wouldn't be able to get down the contrasts that CGI is capable of without HOFUS. So ground in the loop is crucial for this process. SSC kind of fulfills the role of the Starlight suppression processor and the solid state recorder that would have been on board. So we take this role very seriously, and we're very excited to be part of it. So what happens at SSC is we do all the work that the processing needs for hope. So we convert the raw data into the imaging format that the CTC algorithms need. CTC algorithms are that black box that Eric mentioned. Those are housed here, and they run the loop. We feed the data to it. We receive the output. We produce parameters and send commands back to spacecraft. And that is kind of a marriage between the operations and data management sides. In addition, it's a marriage between the event-driven and real-time operations approaches to Roman, because the actual sequence that takes the data for HOPUS and then waits for the ground is an event-driven command sequence that we built using the same process that I talked about with scheduling team, the CPGS, the schedulers going to the observation plan. Data then get downlinked, and we process them in real time and send commands back up using the real-time capabilities of the assist. So again, combining the kind of different capabilities into a interesting whole. And we've tested components of this already in TVAC, in FFT. The data collection procedures that we scripted up, flight, have been tested, were used many times to take data, to take the HOPUS data. Also, the settings upload was used many times to return the data, as well as what I mentioned earlier, the L0, L1 processing was used for the data. So as the data was received, it was run through the L0, L1, and then fed to the HOPUS Skittle analysis. Again, this was on the ground. This was not in the standard ground system setup. And as Eric mentioned, but we did close the loop using SSC created tools. And it seems to have gone very well. And I mentioned also that the HOPUS process for taking the data and converting to commands has already been tested here at IPAC. We have plans, of course, to continue this testing to the full ground system during mission readiness tests under Roman INT. So we've already started. The HOPUS upload proc was used already to upload settings, settings derived during TVAC to CGI during the spacecraft CGI interface test this June. And then we're planning to continue expanding the execution of the HOPUS loop into the rest of the ground system using the infrastructure that I described in future mission readiness tests. So 7C and 8 will be next year, and then there will also be tests in early 2026. Eric mentioned this. There's no light source. There's no means to produce proper data. But so what we'll do is we will inject data at this stage of the process, taken from TVAC, know what the answers are going to be, and run it through the crank. But we will be able to schedule the observations using CPGS, having the SOC for the whole many iterations if we so choose. So this plot, this diagram is a bit complicated, and I just wanted to make a point that the software that we're building for operations and data management are very highly integrated. So the CPGS, from CPGS commanding, planning the observations, creating an output, going into our database. The observation database is tied to the data reduction database, because we need information that comes from the observer to go into those L1 headers that the observer will be able to access. And then, of course, HOFUS is also an integration, heavily integrated loop that includes both ops and data management. So it was a good thing that they both at the same institution. So wrapping up upcoming milestones. We are working on defining visit files based on the prototypes delivered by the CTC. We're working on updating our PROC library so that it can carry out the latest in post TVAC designs for the instrument. We'll be demonstrating our data ingest capabilities for the ground system acceptance testing with TVAC data. Start to integrate the, like I said, the observation specifications information with the data management system so that we can pass the observer specified plans for their observations into the L1 FITS headers. And then we're also going to stand up a prototype data analysis environment later this year. It's going to be tested by users. So in summary, we're working with Roman ground and mission systems and the community to get the most out of the technology. Design and command observations as flexibly and efficiently as possible to execute HOFUS GIDL in an efficient manner. And we're supporting observation planning and data analysis by the CTC and CPP. And we'll be delivering data and documentation to the archive. Our processes and tools have been exercised during CGI tests for FFT and TVAC, as well as the spacecraft interface test. And we will be ready to support on our orbit operations starting commissioning. Our community support work is crucial. That's really what gives us a sense of if we're on the right track, our connections with the community. It's been focused primarily on CTC and CPP, but we expect that maybe you could envision doing us supporting community archival investigations as well with future CGI data. Public data would be extremely useful for researchers, including early career researchers and graduate students. But of course, we're open to suggestions, optimal use of researchers. I think that's it.
Okay, questions for Jim?
So is the chronograph interface to the ground system in IPAC, that now completely verified prior interface, or is there still?
So the interface to the commanding procedures, the commanding procedures that we're writing for flight have been tested on chronograph. We have not tested specifically, if you're talking about being able to use our real-time system and get CGI to do something. We have not tested that yet. It's coming later. It's coming probably next year. Because CGI is not currently connected to the spacecraft. It was connected temporarily.
Software will just have to be updated if there's interface issues.
Well, there was a spacecraft interface test. So the CGI was connected to the spacecraft. The commanding that we've created, the commanding scripts, were run from a workstation very similar to ours at the MOC. They were able to command CGI. So I would say that the risk is very small, and it's very, it's almost unlike, it's almost zero, because same command scripts that we'll use in flight will run from an assist command station at Goddard, connecting through the spacecraft to CGI. The interface was checked out and it worked. We have checked out our command interface to Goddard, and that works through to the spacecraft. So we just haven't closed it all the way to CGI yet. But we went from here to spacecraft. Goddard went from spacecraft to CGI. So I think I can imagine it would be a problem, but we're going to test it, of course. Yeah.